Hello students, welcome to Unit 5 Notes, Section 7.4. I already did the warm-up for you, so take a pause and make sure you have this all written down, and you can unpause when you are ready to continue with the notes. In an interest to save time, I'll continue. So today we're working on similarity in right triangles, and we're going to be using geometric mean. And our goal is to find and use relationships in similar right triangles. So using similarity in right triangles, the altitude to the hypotenuse of a right triangle divides the triangle into two triangles that are similar to the original triangle and to each other. All right, proportions in which the means are equal occur frequently in geometry. For any two positive numbers a and b, the geometric mean of a and b is the positive number such that number x such that a is to x as x is to b. Note that x is equal to the square root of ab. So let me draw an example of what we're talking about here. So if I were to draw a triangle, I'm going to draw something like this, and I draw an altitude. What's really cool about this, so an altitude goes from the highest point perpendicular down to this lowest point. Now it can be inside or outside of a triangle. In this case, we're only talking about the ones that have been in triangles. What's really cool about this is if I label this A and B and C, well, the statement I'm allowed to make is that let me label this one X actually. Label this one B. That would perfectly match, perfectly match what it's asking. So take a look at this triangle here. We have this small side and this larger side, not including the hypotenuse. And here we also have a small side and a long side of this triangle, not including its hypotenuse. Well, what's really cool about this is A is proportional with X, as X is proportional with B. So if I find my cross products, let me erase that. If I find my cross products, x squared equals a times b. And if I find the square root of both sides, I get x is equal to plus or minus, remember there's two solutions, plus or minus the square root of x equals plus or minus the square root of ab. Now we can't have negative values for ab, so in this case x just has to equal the square root of ab. We have to go with a positive result. And that's what this is saying here, is that x is equal to the square root of ab. But here we have, again, short side, longer side is to short side, longer side. And then the hypotenuse are also proportional if we look at them. And what's really cool is that the short side, if we look at this big triangle here, this whole thing, the short side is the hypotenuse of the smallest triangle. The longer side is the hypotenuse of the bigger triangle, and collectively together, we have this hypotenuse here, which is collectively a plus b. All right, so the lengths of the altitude to the hypotenuse of a right triangle is the geometric mean of the lengths of the same. So this is called geometric mean, the lengths of the segments of the hypotenuse. The altitude to the hypotenuse of a right triangle separates the hypotenuse so that the lengths of each leg of the triangle is a geometric mean of the length of the adjacent hypotenuse segments and the length of the hypotenuse. So all of these together are just saying that A is to X as X is to B. It's also saying that A is to its hypotenuse as B is to its hypotenuse. A is to its hypotenuse as X is to this hypotenuse. The small leg is to this small leg as its larger leg is to this larger leg. So we're going to look at this and write each one of the triangles. We'll find the short, medium, and long legs. I think that's the easiest way to work with this. So number one says find the geometric mean of 4 and 18. So the geometric mean of 4 and 18, we're going to have the square root of 4 times 18. That's what this was asking, the geometric mean, the square root of AB. So we're going to say that's x is equal to the square root of AB. So we're going to say x is equal to the square root of 4 times 18. X equals the square root of 72. And we can break this into the square root of 36 and 2. So x equals 6 square roots of 2. We are done. All right, find the geometric mean of 15 and 20. So x equals the square root of 15 times 20. X equals, hold on, this pencil's not working. Okay. X equals the square root of 300. X equals square root of 100 times the square root of 3. So x equals 10 square roots of 3. And so that's the geometric mean of 15 and 20. Okay, so now we're going to actually apply this corollary. So what I like to do is I like to take my small triangle. So I like to take all three triangles. I like to say the small triangle has a short side, a medium side, and a long side. The medium triangle has a short side, a medium side, and a long side. And the large triangle has a short side, a medium side, and a long side. What I do is I kind of ignore all this information. I kind of just put it in this chart, and then I look at the chart and say, okay, what can I work with? What's proportional? What's within ratio to the other piece? So if I look at my smallest triangle, I would say that this one right here, this one right here is the smallest triangle. So I'm going to take a look, and it looks like 4 is probably going to be shorter than this side right here. Yeah, 4 is probably going to be shorter than the y. So I'm going to say 4, and they give me my medium y. Notice they also give me my hypotenuse, which is x. So they gave me short, medium, and the longest side. The longest for all of these will always be the hypotenuse. So you shouldn't get too tricked up on that one. That one's always opposite the right angle. Now in this medium triangle, they gave me y and 5. They gave me what appears to be the short side y, the medium side 5. No hypotenuse. They didn't give me anything for the hypotenuse. Now let me look at the full triangle. This is the short side. The reason why x is the short side is because it's the smallest triangle here. Therefore, the hypotenuse would be the smallest hypotenuse. So they give me x. They also give me the longest side. They give me the hypotenuse here, which is a collective 4 plus 5, which is 9. So now I have all my information. And what I don't know much other than I can connect this small side with this small side, and this medium side with this medium side. And then I can also do this small side with this small side, and this long side with this long side. So I'm going to set up my proportions based on what I know. I know 4 is to y. So again, I'm going 4 is to y as y is to 5. I'm going from triangle to triangle. You don't want to stay within the triangle. And my other statement I'm going to make is 4 is to x as x is to 9. So 4 is to x as x is to 9. So I'll get y squared equals 20. And for this one, I'll get x squared equals 36. And so now I'll find the square root of both sides, and I get x equals 6. and then I'll find the square root of both sides here. And so y equals the square root of 20, which y is equal to the square root of 4, square root of 5. So y equals 2 square roots of 5. That's it. If you put it in this chart, you get to see what you can work with. For instance, you can't work medium and large because y is to x as 5 is to nothing, or y is to x as nothing is to 9. On top of that, you don't want to mix x's and y's. So, it would make sense to do what we did, so we don't mix variables. All right, so again, I'm going to take my small, medium, and large. I'm literally going to copy this. Save some time here. And I'm going to paste it right here. I'm just going to change the values. What are they giving me in this one? Ooh, I'm going to move this over. All right, and so now taking a look at this smaller triangle here, looks like 4 is the smallest side, x is the hypotenuse. Oh, they give me y as well. They do give me the longer side, y. I didn't even notice that one. So they give me all three there. In this medium triangle, we have y and 12, short and long side, medium side, but not the hypotenuse. The hypotenuse was not given. So I'm going to do y and 12. So y and 12. And then in the biggest triangle, take a look, this whole thing, they give me 4 and 12 is 16 as the hypotenuse, and they give me the short side x. So x and 16 they give me. Okay, so I'm going to take a look. Ooh, they give me everything for the small. I'm going to compare, let's see, I'm going to compare the short sides with the medium sides. So 4 is to y as y is to 12. 4 is to y as y is to 12. And then I'm going to take a look here. 4 is to x as x is to 16. 4 is to x as x is to 16. Okay. I'll get y squared equals 48. So square root both sides. We get y equals the square root of 48. Whoops. 16 and 3, I think that is. Yep, 16 and 3. And the square root of 16 is 4. So 4 square roots of 3. This next one, we're going to get x squared equals 64. Third time, x squared equals 64. X equals 8. Remember, these are all plus or minus, but we can only write the positive ones. Alrighty, in example 3, we have a real-world connection problem. Without even reading the information first, I'm going to just look at the diagram and see what's going on. Looks like we have a parking lot over here. We have what is that? That is a information center, I think. This is a dock where the canoe rental is located. And it looks like we have a triangle, another triangle, and then a third similar triangle with the large one on the outside. We have some values like x, we have 300 meters, we have 400 meters. Yeah, and so let's see what information we can pull from the text. So it says the 300-meter path to the information center and the 400-meter path to the canoe rental dock meet at a right angle at the parking lot. Here's a parking lot. There's your right angle and your 300 and 400. And it says Marla walks straight from the parking lot to the lake as shown, where a sign tells her that she is 320 meters from the dock. So I'm gonna actually write that information in. We got 320 meters. And so it says, how far is Marla from the information center? Well, I'm gonna take my information. So I'm gonna take these. I think I'll be able to reuse that. That fits perfect right there. And the large, I'm just going to copy these over and change the values and see and figure out what I'm going to be able to set up here. Let's see what we can set up. Which ones work? So in my small triangle, I was given x as my short side and 300 as my longest hypotenuse side. So x and 300. In the medium, I'm given nothing for this value, but I'm given 320 as my long side, as my medium, and then the hypotenuse, which is the longest, I have 400. So I have 320 and 400. And then the large one, I'm given, let's see, we're given 300 and 400. So I'm given 300 and 400 as my small and medium. And I'm not given a lot, well, let's see. Look at how these two don't match up here with these two. And these two don't match up with here, these two. All right, and then these two, top and bottom, don't match top or bottom here or top or bottom there. And then these two bottom ones don't match these two bottom and these two bottom. So we need a little bit more information. So let's go back, and all of a sudden I see that we missed one of our values, which is actually x and 320 meters. So that whole side as a hypotenuse is really x and 300 meters. So now I see what matches, and these are what match. X matches with 300, and 300 matches with x plus 300. So this is what I'm going to use to solve for x. It might yield a quadratic, but we'll deal with it when we get there. So x over 300 equals 300 over x plus 300. And I'm going to, that will be 90,000. So it looks like I get x times x plus 300 equals 90,000. And that will give me x squared, because I'm going to distribute, and 300x equals 90,000. All right. And what I'll do is I'll move 90,000 over so I can solve, because I will put everything on one side. What I get now is x squared plus 300x minus 90,000 equals 0. And I can factor this, and let me think here. What factors of 300? Wait a minute, I did something incorrect. My bad. This was supposed to be 320. 320, I messed up here. So let me just, it won't do too much damage. Let me change that to 320. I was going to say, because I don't think this factors well. I'm going to change that to 320. And now that will change to 320. And this will change to 320. And now this will change to 320. Very, very cautious here, but I made a mistake. So that simplifies to 320. So now I'm going to look at and see what factors, what are some factors of 90,000. So 90,000, well, I can do, this is totally separate, but if I divide it by, let's say 100, what I get is 100, and I get 900. Those are 2 factors. So that adds up to, that would be a difference of 1,000 or 800 or negative 800, depending on how I break this apart. So yeah, if I did that, whoops, if I did that, because negative 100 times 900, so I need to go a little bit more. So what if I did 200, negative 200, I would get 450. And those factors don't work. You don't have to write these down. I'm just going to go through a couple factors, right? 200 times 450 gives me negative 90,000, but 450 take away 200 is 250, and that's not enough. So this was too much. That was 800. This is 250. It's not enough. So what other factors? So I need to go somewhere in between 100 and 200. So I can try 150 maybe. So I'm going to do 90,000 divided by 150, and I get 600. So negative 150 and 600. Well, that gives me 450. So that is too much. Okay. Wait. 450. Yep. And so let's see. What about 90,000 divided by 180? 500. Ooh, I'm liking this. What if I had negative 180 and 500? Let's erase these. What about negative 180 and 500? Negative 180 times 500 is negative 90,000. Also, 500 take away 180 is the 320 I'm looking for. So that I had to increase because I wasn't at enough when I had negative 150. I'm liking this. So I'm going to say that this is going to factor into, I don't like that. Let's go back to that original color. So we'll do x minus 180 times x plus 500 equals 0. And now I'm going to solve this. I'm going to say x minus 180 equals 0. Move it over. You get x equals 180. And then this solution is x plus 500 equals 0. Because if this was 0, 0 times anything is 0. If this was 0, anything times 0 is 0. So I'm looking for both options. So the number here would have to be 180 for it to become 0, and it would be 0 times 680. That's 0. Now this one, it would have to be negative 500, right? Negative 500 for negative 500 to work to be 0, and that would be negative 680, so it would be 0. But what I know is that I cannot use a negative value. Oops. I can't use a negative value for a side length, right? That can't happen, so x is 180. So here we have x is 180 meters. So you have 180 and 320 meters, making that whole length 500. Okay? How far did Marla walk from the parking lot to the lake? So now here's the question, how far did she go here? And now I can use that setup. Again, I can now take my items. I'm going to take my small, medium. I'm just going to see what I can set up here. I'm no longer going to use, I'm not going to use x plus 320. I'm going to get rid of that. I'm going to get rid of that. X plus 320 is actually not going to be that. I'm going to use the number 500 because the hypotenuse is also equal to 500, right? Because 180 and 320, so we get 500. And so now what I want to know is what is this value right here? What is y? So y can go here and y can go here. It's the small side or the medium side. So I can work with whatever I want, but I have all my large values here. So I can work with these over here. So I'll do these two. I'll say, okay, y is to 300. So y is to 300 as let's just do 400 is to 5, 400 is to 500. We could do, no, let's do 320 is to 400. All right, 320 is to 400. Oh, and don't forget, this x we already know is, what did we get? We got 180. So we can change this one now to 180. Okay, so I could have done, actually I could have done the small. I would have ended up with y squared if I did that. And it would have been actually pretty quick to solve that one. So I will do y times 400 is 400y. And 300 times 3, oh, hold on. And 300 times 320 is 96,000. So divided by 400. We get y. Why is this pencil doing that? Hold on. Let's try that again. Divide both sides by 400. Still not working right here. Divide both sides by 400. We get y is 240. Okay, so this is 240 meters. All right, so Marla walks 240 meters. All right, that's it. And so we'll be doing 7-4. So that's good. So the answer was 180, which I circled, and meters. I should really say meters. And 240 meters. Okay? And we'll start this in class. So good luck.